Verses. After the sun has set, the land cools more quickly than the water. Therefore, the air above the land also cools down. Cool air, being more dense, presses down over the land, creating an area of high pressure. Meanwhile, because water cools down slowly, the air over the ocean is still warm. Warm air, being less dense, expands and rises, leaving an area of low pressure over the water. At night, cool air over land moves towards lower pressure over the ocean. This air is warmed by the water and rises, and the cycle continues. Winds that blow from the land to the sea are called land breezes.
Oh, yes, I'm back. Yes, Priyanka
Sir,
and Abu. Yeah. Yes, I'm listening. Habib, you can continue with from the next class. Okay, Habib. Your class timing is. Priyanka, were you saying something?
what? Can you tell again?
Habib, your class timing is over. Your class is over. You have to continue from the next class. Okay, no?
Okay. So shall I leave?
Yes, you can leave. Okay. Yeah, Priyanka and Abu, let's continue with this discussion. We were done discussing about conduction. We were talking about convection, right? How heat travels by the method of convection. So in this, we were talking about this phenomena, that is land breeze and sea breeze, that is also happening due to convection. And it's a day-to-day phenomena that we get to experience. Let's understand this one. Am I visible to all of you or not?
Yes, sir, you are visible.
Yes,
Okay.
sir.
So see what happens now. In convection current, we discussed that the particles of the air, or whether it be of liquid, it moves from hotter end to the colder end of the object. Just like in the case of boiling water, the water molecules at the bottom of the utensil, it moves from there to the colder part of the water. While in the case of conduction, we have studied that it's not that the particles moves from one place to another, but by vibration, particle passes on their energy to next particle. In this manner, heat is transferred in conduction. While in the case of convection, we study that here what is happening, the particle is moving from one place to another and thereby transferring the heat. So that was the major difference between the two. Okay, now. And in the case of boiling of water, you have seen that water molecules are moving up and down in a cyclic fashion. It moves in a cyclic fashion, and thereby it was being called as convection current. What we call this cyclic movement as
Convection current.
convection current. Let's understand about sea breeze and land breeze, which we were discussing in the sea breeze and um, yes, let's understand about this in detail. See, what happens during the daytime, during the daytime, as we have discussed, saw by the animation, that the air above the land heats up faster, because land gets heated faster as compared to water. Water takes more time to heat up. So during the day, the air above the water, the air above the land is warmer as compared to the air above the water body. So thereby the air here starts to rise up. So rising air creates a gap. So those gaps are taken up by the air that will be coming from the water body. Uh, So in this, what is happening? The hot air is rising and thereby creating a gap over here. And this gap is taken over by the cool air that is coming from the seaside. While during the night, what happens? Opposite happens. Now you know that I did told you that land heats up faster and cools down faster, while water heats up late and it also cools down late. Hmm? So during the night, what would happen? Now the water is still warmer because we know it is the property of the water that it takes more time to warm up and it takes more time to cool down. So during the night, it will still be warmer or not? Answer this to me. It will still be warmer, no? Warmer?
Yes, sir.
Huh? So during the night time, what happens? The air above the water body is still warmer, so air will start to rise. Air starts to rise here. So rising air above the water body during the night time will create a gap here, and this gap will be taken up by the air above the land. The air above the land will be rushing towards the water body to occupy that empty space. So that is what happens during the night time. So this is happening due to the difference in the temperature, in the difference in the temperature of the water and land. So that is what the concept of land and sea breeze is, right? So when the wind will be when the wind will be blowing from the land towards the sea, as in the first case, what is happening? The wind is blowing from the sea towards the land. So what do we call this as? Yes, as we
Sir,
have discussed,
Land breeze.
that is,
Sir, I didn't understand.
see, my question is now, we have terminologies like land breeze and sea breeze, but which one is called as land breeze and the sea breeze?
Land
Land.
breeze is when the wind goes from
During night.
the land to the sea, and then the sea breeze is when the
Wind blows
from the sea.
from
Yeah.
sea to the land. Huh.
Yes.
So during the day, what is happening? Wind is blowing from where to where? From the sea to the land. No?
Yes.
The
Yes,
first
sir.
image is that of a sea breeze. Keep this thing in mind. So in the sea breeze, you'd find that the wind is blowing from the sea towards the land. So thereby that is sea breeze. You would experience very cold and gentle winds coming from the sea. So that's why people go to the beaches and during the daytime, the cold and gentle winds would be coming from the sea. People take sunbath also at the beaches. Then at the night time, the wind will be blowing from the land towards the sea. Hence, it is called as land breeze. Breeze refers to cold and gentle air. Breeze refers to cold and gentle air. Right now, sea breeze will be happening during day or night. This
Sir, day.
day. Land breeze will be happening when?
Night.
Night. Okay. Now you can observe this phenomena happening at a bigger scale also. The phenomena of sea breeze can be observed at a larger scale also. See what happens now. Our Indian peninsula, this Indian peninsula is covered by water body from three sides. Now you have the Arabian Sea, here you have Indian Ocean, and here you have Bay of Bengal. So due to the uneven heating of land and water body, the winds from the water body, particularly from the Arabian Sea and the Bay of Bengal, will be rushing towards the northern parts of India. So this is a sea breeze or land breeze. That is again an
Sea breeze.
example of sea breeze right now. So
Yes,
that
sir.
is the thing. So hope you guys have understood what is land breeze and sea breeze, and their convection is playing a role. And keep that property also in mind that land heats faster and cools down faster, because that is very important. Okay, no? And water cools down slow or faster? Water cools down
Slow.
faster or slower?
Slow.
Slower. Hmm. And will also take more time to warm up. Let's understand what are the practical applications of convection in our house. So you have some of the practical applications in a house as follows, like exhaust fans in the kitchen. You guys know this, that warm air rises up. Huh? Warm air rises up. We all know this thing. So that's why you see that exhaust fans in the kitchen or in the rooms are fitted at the top. Ventilators are also provided at the top. Huh? Have you ever seen a house in which the ventilator would be provided at the bottom? Usually no.
Sir.
Getting it now? So it is that the hot air is rising up. So thereby exhaust fan would be placed at the top of the room, at the top corner of the room.
Sir, it could happen when the area is a cold place.
In the cold place, you want to do opposite. So there you don't want that the heat from the room escapes. In the cold areas, there you don't want the heat to escape from the room. You want the room to be cooler. So there you would be you won't be having any ventilators in the room right now. Particularly, there won't be any ventilators at the top of the room. You might find ventilators at the bottom. Okay, no, at the bottom of the wall. Room heaters, why they are placed on the floor of a room? Why not we place it at the top corner of the room? Because we know that hot
Sir,
air. Mhm.
sir, because uh, the room ventilators, they will take cold air in and make it hot. If they take hot air in and release hot air, that doesn't make a difference.
See what will happen now? Like say that if I were to place the room heater at this corner of the room, somehow I place it over here via a stand or something. What will happen? Why the Since we know that warm air will be rising up. So warm air will rise up and via this ventilator it will get out. This is ventilator, and say that here you have placed a room heater. So will warm air it will go outside the room from this ventilator. The room will not be cooled down in this manner. So that's why a heater or a fireplace is at the bottom of the room or placed on the floor of a room, so that it gives out heat and it warms up the room. Getting my point or not?
Yes, sir. That's why
Hmm.
air, air conditioners are at the top.
At the
AC.
top, because cold air is heavier and it will spread into the room, it will expand into the room. Cold air is heavier. Getting it, guys? Cold air is heavier, it is having more density. So cold air will come down from the air conditioner. Very good, Abu. Then you have
Sir, but
ventilators. Yes.
it will take time to go up because, sir, uh, like, sir, we have a bunk bed. So then when I sleep up and in the air conditioner, right?
Mhm.
That time it will take time for the whole room to be cool.
You have a which bed?
Sir, a bunk bed, like
Bunk bed.
this bed, and then there's
Okay,
Sir.
a
got it.
bed
Oh,
at the
got
top.
it, got it. A bed over another bed,
Yes,
Yes,
sir.
which you climb using a stair. Yeah, that one.
yes,
Yes.
Got it. Then it will take time. So basically, the concept is that warm air rises up and the cold air it comes down. Right, it comes down and it will spread into the room in this manner. So that is the thing. So that's the ventilators are also at the top of the room. Even the windows are at the top. You have another example. You have an hot air balloon. Hmm. So since warm air are having a less density, so this candle or whatever burner is there, it will be warming up the air, and the warm air will keep on rising. It will keep on rising, and it will apply a rising force above it, that will be called as buoyancy. It's a same kind of force that, for example, if you were to invert a glass, you invert a glass and you try to push it into the bucket of water. Do you find it difficult to do so? See that you
Yes.
have taken a bucket of water and you have taken an empty glass, inverted it, and you're trying to push it into the water, you will find it difficult. Unless you tilt it a little bit, only then you'll be able to push it. Otherwise, it becomes a little bit difficult. So there's a upward force that is taking place, that is acting on this glass of water, empty glass of water. That upward force is called as buoyancy force. That is called as buoyancy force. It's the same force because of which boats are able to float and not sink. Boats are able to float in the water body because of the upward force that is acted by the water. Getting my
Sir,
point, both of you? Yes.
yes, sir. But then the ships also tilt.
Ships also tilt, but still you see that force of buoyancy is acting on it. It only ships will sink only in that case if the tilt is too much. Ships are designed in such a manner that up to tiltation of some angle, it will not be sinking. But if the tilt is too much, like you have a ship like this, for example, say I'm talking about the front portion of the ship. Let's say this is a ship, for example. Let's say for example, up to some angles, it will be able to tolerate the tilt and it will not float. But if the tilt is way too much, then it will obviously sink. Basic concept here to be understood is that there's an upward force acting on this empty glass of water or on the boats. That's why they are able to float. In the similar manner, an upward force is exerted by the warm air on the hot air balloon, on the cloth of the hot air balloon. That is called as force of buoyancy, and it is acting opposite to the resisting force that will be there by the cold air. Like normally when you go higher up in the air is cold, and cold air have got more density now, it has got large density. So they will be applying a downward force, like we studied about the cold air, that they try to come down. So they will be applying a downward force or not. Cold air having large density will apply a downward force on this hot air balloon. But due to the warm rising air, it will also apply an upward force called as force of buoyancy. Because of this, it rises up in the air. And you can control the height to which hot air balloon is flowing by increasing or decreasing the flame of this, by increasing or decreasing the burner. Right now, and once it is switched off, so thereby it will start to come down to the ground. So hope you guys have understood this. Here are some other practical application of the same one. This is an exhaust fan, this is the ventilator, this is also having an exhaust fan in it. So considering the concept of convection, this thing is done. Hope it is clear to everyone.
Yes, sir.
Then let's understand about radiation. This is another method of the transfer of heat. You see, so far we have studied that whether we talked about radiation or whether we talked about convection, there was a medium in which heat was flowing. There was a medium now in both of the cases. While there's a radiation, there's another method in which medium is not required, like medium such as air or liquid. These will be not required for the transfer of heat energy in the process of radiation. For example, the heat that is coming from the sun. So is there any medium between sun and earth? Is there any such medium like air or liquid between earth and sun? Obviously no. There is vacuum between earth and sun. Huh? But still heat is able to come from the sun to earth. So that is because of another method called as radiation. So see, like one feels warm when you are standing in the sunlight. The heat from the sun, it cannot reach the earth directly by the means of conduction or convection, because conduction and convection requires a medium, while vacuum is the only medium in majority of the region of space between earth and sun. So the process through which the earth receives heat from the sun, that is called as radiation, and no medium is required for the transfer of heat by radiation. The transfer of heat can take place even if a medium is present or not. That's what we can conclude as of now. The transfer of heat can take place even if a medium is present or not. So for example, you can feel the heat from a room heater in cold regions. You can feel the heat from a room heater in the cold regions. Or a hot utensil that is removed from the flame, it cools down if you have a hot utensil, hot kitchen utensil, as it is removed from the flame, later on it starts to cool down. How does it cool down? Because it transmits its heat to the surrounding by the process called as radiation. You guys getting my point? Like how the heat is coming from this fireplace towards you. It is by the process of radiation. So radiation is that method of transfer of heat that it does require it can travel without the medium also. Like in the case of sunlight, we saw that it does not require medium. While even if there is an availability of medium, even there radiation will work. You guys getting this thing or not? Also pay attention here. It's a horizontal movement of the heat towards you. It's not a convection. Like convection will also be taking place over here. That's for obvious convection will be happening. But heat towards you, how does heat comes towards you? Like what we have studied, that heat is supposed to go upwards now. Like in the
Yes,
case of convection, there was upward and downward movement of it. There was a cyclic movement like this, isn't it, guys?
yes, sir.
Huh? But here you see that heat is able to travel in the form of waves towards you. So that is radiation. So the transfer of heat in the form of rays for which a medium is not required, that is called as radiation. And these waves can move through vacuum also. So the sun, from sun, electromagnetic waves are coming. That's how heat comes on earth. For example, see this one. There is space. There's no medium present between the earth and the sun. It is only in the atmosphere of the earth that when the sun's rays reaches and it comes into a medium. So there are some common examples of radiations like ultraviolet light from the sun, heat from a stove burner, visible light from a candle, or X-rays from an X-ray machine. These are different examples of radiation. I believe you guys might have heard of this term radiation before also. Like when you get an X-ray done, so there you'd be might have read this term somewhere. Have you guys?
Yes, sir.
Hmm? Right now. So as I was telling again moments ago, just how a hot utensil kept on a burner, it cools down after some time because it starts to lose its energy, lose the heat. It is transmitting the heat to its surrounding by the process of radiation. It transmits the heat to its surrounding by the process of radiation. Like this one, just let me clear these things, okay, now, so that it doesn't become quite complicated for you guys. So you observe this thing, like you have a cup of tea, and after some time, the tea in the cup becomes cold. Why does that happen?
Because the surrounding is cold, so then
Basic thing is now that it
sir,
starts to lose heat by the process of radiation.
yes, sir. Sir,
Okay, no?
the heat of the cup uh, go like moves to the air.
Exactly. It loses its heat right now by the
Yes,
process called as
the in the
Mhm.
Radiation.
radiation, right? And how does heat travel in the in this radiation in the form of waves? Okay, no? So keep that thing also in mind. Now, radiations are emitted by almost every bodies. Almost everybody's right now. Now, the rate at which they will be radiating will depend upon different factors. For example, it will depend upon the color and texture of the surface. Color and texture of the surface. It will depend upon the surface temperature. It will depend upon the surface area. For example, if the surface area of something is bigger, say that there are two bodies, body A and body B. The surface area of B is more, so it will be radiating more amount of heat. Okay, now more radiation will be observed in body B because of the surface area. Surface temperature also defines the radiation. So there are different factors that define rate of radiation. It could be temperature, it could be area. You guys getting the point or not?
Yes, sir.
It would also be dependent upon the physical state of the substances also. Like water in its liquid state will radiate more amount of heat as compared to in the solid state. Okay, now?
Sir,
Yes,
are we going to write?
these things.
Yes, sir.
Okay, you guys tell me, like, so far, what are the things you guys have noted down in this chapter so far? How much you have noted down?
Sir, I have not noted anything.
Not
Me
noted
too, sir.
anything. Yes, Priyanka.
I also didn't write anything.
Okay, okay. So see, do one thing now. For this class, I will be providing the PPTs for you guys. But as of next class now, we would be making live notes. Okay. Also,
Sir,
do tell me the yes.
Sir, we'll write now.
We write notes. You guys have written anything as of now or not? Like nothing.
No, sir.
Yes, sir.
Okay. See, if I once I provide the PPT to you, okay, it is only so that you take some help from the PPT while preparing the notes. Don't entirely rely upon this. Okay, now. Okay, next thing, one more thing you guys tell me before we continue further. Do tell me in your school which chapter has been finished and which chapter is going on in science.
Sir, for me, nutrition and animals has been done and chapter 8 is going on.
Okay, nutrition in animal is done and chapter heat is going on. What about nutrition in plant?
No,
Not yet.
no.
Okay, but in the batch we have done that, right?
What,
You
sir?
were present, but in the batch we have done that chapter.
Yes.
Okay. Okay, what about you, Sumaya? Priyanka?
Sir, actually, today I was absent, so I don't know, sir.
Okay. Okay, before that,
Before
till
that,
you attended the last class. Yeah.
Sir, today is
nutrition
holiday.
and in physics, heat we finished.
In physics, heat is finished.
Yeah. And
What
bio,
about other?
nutrition animals finished.
Nutrition in animal is finished. What about nutrition in plant?
Nutrition plant finisher. We are going to start nutrition in animals.
Okay, going to be started.
Yeah.
Okay. Since you were absent, I believe it might be started. Might have been
Yeah.
started. Okay. Okay, so let me repeat about this radiation once again. Normally, students get confused in this. Okay, now see, normally as you talk about light, for example, light can move from one place to another and it does not require medium. Hmm? Similarly, the heat energy can also be transmitted as light. Huh? It can also be transmitted as in the same manner as light is transmitted. Like light to come from sun to earth, it does not require a medium now. Right now.
Yes, sir.
So you see, we have talked about conduction also. Conduction requires contact, while in convection, contact is not required, but medium is required. Keep that in mind. In conduction, contact is required. In convection, contact is not required, but a medium is required. Right now. While in the case of radiation, neither contact, neither medium is required. You guys got this point or not? The best example of radiation is the sun heating the earth. There is a direct transfer of heat from one object to another in this case without air being heated in this. Keep this thing in mind that in radiation, what is happening, that air itself is not getting heated up. Try to understand what I'm trying to say. See, while the heat is coming from the sun on earth now, it is not heating the medium between it. Like for example, you go to the like you can observe this in this manner, like you can feel it in this manner, like when you are out there in sunlight, it's you feel the heat because of the sun's rays, because of the sunlight that is falling on your body. But let's say that you are in an open sunlight, in an open air, and let's say you are under a shade. So under the shade, do you feel the warm? Do you feel hot under the shade? Let's say that it's a hot sunny day. So say that what I'm trying to prove here is now that radiation does not heats the air. Radiation does not heats up the air. That's what I'm trying to prove here. For example, if you were to stand at this place, you would feel warm. Huh? You would feel warm. While you stand under this shade, you will feel not warm. You won't feel warm. If it was true that radiation heats the air, so wherever the air is, it will be getting heated up. Whether it will be air of this place or whether it be air under this shade, it will be getting heated up. You guys getting my point?
Yes, sir.
So radiation is such a method which does not require contact or a medium, and it's a direct transfer of heat from the one object to another, and without it does not heats the air in between. Okay, no? So the sun is able to warm the earth without warming the space between the sun and earth. Let me write this over here. The sun is able to warm the earth without warming the space between earth and sun. Also, radiation requires no contact and medium. Radiation requires no medium and contact, and it's a direct transfer of heat. How does heat travel? In the form of waves. You have different types of different types of objects, like you have a glass, you have so many translucent materials, even you have earth, even you have the atmosphere also, which these different materials, these different mediums passes a significant amount of radiant amount of heat. You have different type of examples of radiation. For example, you have heard of radio waves. You have heard of microwaves. You have heard of heat radiation. You have heard of heat radiation. So that is the thing about radiation. Hope it is clear. So how do you be defining radiation? Yes,
Sir?
Priyanka and Abu. Yes.
It is
Sir,
a
I've heard radiation from air fryer.
Radiation from
Air fryer.
air fry. I didn't get it properly. Please repeat again.
Sir, I have heard radiation from air fryer. Sir, because while you put something in an air fryer to cook it, it uses some type of thing, and then
You are saying radiation is used in air fry.
yes,
Okay, air fryer. You're saying microwave, no? Microwave you're talking about, I believe.
no sir, micro is something else.
Radiation is used in air fryers. Air fryers. I'm not getting it. What air? Okay, air fryers are same. It's it is used for cooking purpose, right?
Yes.
Okay. So see, usually they say that they don't use radiation to heat the food, as the microwave uses radiation to heat the food. But certain people, they say the manufacturers of air fryers, they say that the fryers don't use radiation to heat up the food. That's what they
Yes.
have to say. Yeah.
That's why, sir, we don't buy this microwave.
Okay. Okay.
Then
Because
Sir,
if we,
my
then there would be a lot of radiation in the food.
yeah, there
So
would
it
be
will,
radiation. Mhm. Okay, okay. Yeah, that might be problematic in some cases, right now. While talking about the microwave, like microwave uses radiation to heat the food. And talking about an air fryer, look at the name of the appliance, air fryer. So it would be generating heat from a fan and it circulates it around, just like a convection takes place now. Like you have a convection oven. So it is pretty much based on the concept of convection. You have seen an air blower, like you have we have room heater, then you have blowers that emits hot and warm air, that emits warm air. Is it is pretty much similar to that. Getting it, guys?
sir, that
yes,
air fryer, flare
Air fryer. Yeah, let me write it. Air fryer.
is actually it bakes or bo-
It is used
it
for baking,
bakes
no,
and
sir, it is
toast.
not sir. Baking.
not for baking, for simply warming up the food, heating the food.
Yes,
And
Mhm.
roast.
Roast it. Okay, okay. See, I believe that it is similar to just how hair dryer works. Kind
Yes,
of similar
sir.
to that. Similar to that, right now. So that is the thing. So it is obviously better than the microwaves. So hope you
Yes,
guys have understood what is radiation. You
yes,
define
sir.
to me what is radiation.
It is a process of
Hmm.
transfer of heat
Hmm. Yes.
in a material medium is not necessary.
Yes.
Heat is directly transferred
Hmm.
from one body to another.
Okay. So radiation basically is the process where heat waves are emitted from an object, and it can travel from one place to another without the requirement of a medium. You have an example of sun that emits the heat in the form of electromagnetic waves. You have different other examples also, like fireplace, like how a cup of tea becomes cold. That is also because of radiation, because it will be radiating the heat. Okay. Then here are some of the examples of radiation in your daily life. Like as we were talking about a microwave oven. So there, electromagnetic waves are used. Electromagnetic waves are basically what? Like, as I'm saying, that radiation is the transfer of heat in the form of waves without the necessity of a medium. And heat is traveling in the form of waves. What form of wave? It is electromagnetic wave. You'll be studying about it in higher class. As of now, just know that the waves that we are talking about, these are called as electromagnetic waves. So due to the radiation, that is due to the electromagnetic waves, foods are cooked in the microwave oven. Then you have a radiator. Heat is emitted out by a radiator. You have solar ultraviolet radiation, precisely the process that determines the Earth's temperature. So solar ultraviolet radiation is also there. Then you have light that is emitted by an incandescent lamp. Incandescent lamp, it is talking about the yellow bulbs that were earlier used. So you would find observe that apart from giving light, it heats up the air also. It heats up the room. Right now, it heats up the room also. So that is also emitting radiation. Then you have emission of gamma rays by a nucleus.
Sir, I didn't understand, sir.
This one. See,
Yeah.
you have yellow incandescent bulbs. Like earlier, people were using the yellow incandescent bulbs. Nowadays, it is not manufactured. Usually, it was of 100 watt. It consumed lots of electricity. You're getting it or not? Let me show you. If
No, sir.
You got it?
Yes, sir.
Good. Then gamma rays are also emitted. Gamma rays are emitted by nucleus. See, see, when you look at the atoms now, when you look at inside the atom, you have nucleus. So see what happens when an atom goes under, when an atom is decaying, huh? When an atom is about to decay. So they would be producing very energetic. They would be producing some rays. See, the gamma rays now would be produced by some of the most energetic objects in our universe. For example, there would be some, like you guys have heard of supernova. Supernova, or have you heard of nuclear explosions? Nuclear explosions, you all have heard of nuclear explosions. You might have heard of neutron stars. You have heard of black holes. Hmm?
No, sir.
Okay, let's come to Earth. Let's say on Earth, you have heard of nuclear explosions, right? So while there is a nuclear explosion, while nuclear bombs are exploded, so that releases lots of gamma rays. Right now, so gamma rays consist of heat. So the heat that is emitted out during a nuclear explosion, it is due to the gamma rays. Let me repeat. During a you have an example of a nuclear explosion. In the case of nuclear explosion, what happens? Gamma rays are emitted from the nucleus. Like let's say this is an atom. Inside the atom, you would be having the nucleus. So from the nucleus, gamma rays are emitted out, and these gamma rays are emitting out heat. They consist of lots of heat. Then you have some other practical example application. By the way, please tell me, is this thing clear?
Yes,
No,
sir.
Priyanka, see basically what happened. You know about nuclear explosions. You had different type of nuclear weapons.
yes, sir.
Nuclear weapons are there. So whenever a nuclear weapon is exploded, it will release lots of heat. And where does that heat come from? You know, like temperature can usually reach to tens of millions of degrees whenever there's a nuclear explosion. It can go so much higher, like it can reach millions of degrees Celsius. So in that temperature, you see anything that is close to the bomb, it will simply evaporate. Like the humans, if there are some humans, they would simply evaporate. That's how it is. That's the amount of heat that it generates. Where is that heat coming from? It is due to the gamma rays that is coming out from the nucleus. Okay, no?
Okay, sir.
So that is the thing. Hope you guys are able to understand that. Then you have some of the practical application of radiation in our life. Application. For example, you all have heard of solar heaters, I believe. Huh? Maybe I have an image of it. Okay, no. See, basically what happens, solar heater, it uses the heat energy from the sun for cooking food. Let me show you an image of it. You will be getting a better idea about it. That is solar heater. Apart from that, you have one more example, one more practical application of radiation in your daily life. Like in the summer season, what kind of clothes you would prefer to wear? Light color or dark color?
Light color clothes.
Exactly. Hold on for a minute, it's not loading. Okay, see, uh, it's stuck here. 1 minute. So while in the summer season, you would prefer the light colored clothes, huh? Because light colored clothes are poor absorbers of heat. They are not good absorbers of heat, so they radiate the heat. While in the winter season, we prefer to wear dark colored clothes. What is the reason for doing so? Because they are good absorbers of heat and thus keeps us warm.
Sir, that's why
Mhm.
the solar heaters are colored black.
Yeah, that's why they are colored black. Okay, now. So concept of radiation is applied in solar cooker right now. So a solar cooker, it's simply a kind of, it is collecting the heat from the sun. It traps the sun's heat right now. It kind of traps the sun's heat. And that's why, as I said, it is colored usually black in color, because black color are good absorbers of heat. So it is designed in such a manner that it will trap the heat from the sun and thereby keep the food warm. 1 minute. Don't know what just happened, but it was stuck.
Sir,
Mhm. Yes, I'm
sir, I
listening.
was, uh,
Yeah.
sir, I had a picture of this sir back.
Solar cooker.
No, sir. Sir, in Canada, sir, like in a place there was this type of
Mhm.
sir, in the sky there was sir. When you imagine of universe, there would be a lot of colors. That type of picture. Sir,
Okay.
basically,
Are you
yes,
talking about auroras?
sir. I
Like
don't
you,
know.
like you'd find that be having greenish or bluish color. Are you
Yes,
talking
sir.
about that
Green,
thing?
sir. Many type of colors.
So you are not talking about auroras. Okay, no, they are called as aurora. See, that is due to the magnetic field of Earth. That is due to the magnetic field of Earth right now. So thereby you would observe that. Huh?
Sir, maybe
Also,
you
there's
have seen.
yes,
Sir, maybe you have seen it.
yeah,
Sir,
I
like I
have,
put it.
yeah, I saw that. I saw that. I get it. What you were trying to discuss. What you were trying to say. See, aurora would be seen in different countries. Like in Russia, you'd be able to see it. Like in some parts of Germany also, you or in some parts of Australia also, you can see it aurora. So what are aurora basically? What are they basically? See, basically what happens now. Um, what happens in, you know that our Earth has got a magnetic field, right? You all know that our Earth has a magnetic field. Please tell me, you guys know that or not?
Yes, sir.
You know what Earth has got a magnetic field.
Yes, sir.
Again, one more thing you need to know, that many time what happens, sun releases flares of heat. Sun releases flares of heat from it. Hmm? So what is basically happening when there are some ions in our sky? When there are some ions in our sky, when those ions are now basically energized particles that will be present in the sky, when they interact with the Earth's magnetic field, so thereby they start to interact with the gases present in our atmosphere, that gives you different colored light in the sky. Let me keep it simple for you guys. Hope you I think you guys might be getting confused what do we mean by ions. See, there are some charged particles. Now is it clear, like there are some charged particles? Huh? there will be some highly charged particles, highly energized particles present in the present high in the sky, only in some parts of the world. So those, when they come in contact with certain type of gases, and when they are under the influence of Earth's magnetic field, they give off interesting light colors. Pringa, are you getting it? Abu, are you getting it? Let's try to understand it in this manner. See, there are some charged particles. Yeah,
Are you saying about auroras?
yeah, I'm talking about auroras.
Oh.
Okay, na? So,
Sir, it a colorful, right?
yeah, it is colorful like this. See,
In the sky, sir.
in the sky,
Okay, sir.
you would have seen it.
No, sir.
Okay, like in images, you must have seen it.
Yes, sir.
Okay, see, like this. See this over here. This is what Abu was talking about. Hmm. So this is an interesting display of beautiful colors, and why it happens, because as I said moments ago, that there would be some energized particles which would be present in the Earth's atmosphere, and once they react with the different kind of gases in the atmosphere, they gives different colors. Right now, so it has got to do with that thing. Okay, let's continue with what we're discussing. You all might have seen that from the front portion of the car, it would be emitting heat. Like even in the older models, it was emitting heat. So a radiator is installed in the car to radiate the heat from the engine. So that is also working on the principle of radiation. Then at the room also, this person is installing, there are some this pipe-like structure that you're seeing over here. It is filled with warm water. And why it is being done? So that during the winter season, room stays warm. So there
Sir,
also the concept, yes,
I have it.
you have it. That's good. Okay, na? So that is the thing. Okay, na? So that was the thing. Now let's understand about how a thermos flask works. We are done discussing about the three modes of transfer of heat: conduction, convection, and radiation. Now you all have used this thermos flask or would be using this. A thermos flask is used to maintain the temperature of liquids that are kept inside it, whether we want to keep it warm or we want to keep it cold for a longer period of time. See, the outer casing of this thermos flask will be made up of a plastic or could be made up of metal also, right? So this will be now acting as an insulator. Usually it is made up of plastic in most of the cases. There would be an extra covering above the plastic that would be of metal. There would be an extra layer above it that will be made up of metal. So the outer casing of this thermos flask is made up of plastic, and we know plastic is a bad conductor of heat. So it will not allow the heat to pass through it. Okay. Inside it there will be a double wall container which will be made up of glass or stainless steel. So right now we are talking about the innermost structure, this one over here. So this one would be either made up of glass or either it would be made up of a stainless steel. Now if you were to see, like almost 10 or 12 years ago, the thermos flasks that were made, the inside of the thermos flask back then were made up of glass, but since it used to break, so thereby nowadays we have got stainless steel, right? So that is the inside layer of it, and it is a double wall container, right? Now keep this thing in mind that the outermost layer will be made up of plastic, and again to make it strong, it will be covered with metal. There will be an extra casing of metal above it. So now keep in mind that this innermost layer and outermost layer, between them there is a gap. Between them there is a gap, and this gap is basically vacuum, no air, nothing. So this gap between the two layers of thermos flask is vacuum, and vacuum is also like, air is a bad conductor. And what about vacuum? Vacuum will not allow any amount of heat to pass through it. Okay, na? So several things are happening here. See, due to the vacuum, the heat will not be not escape from inside of the thermos flask via convection. Because if it were to be filled with air, so thereby the heat will be lost through convection. But since there is a vacuum, so thereby heat will not be lost through convection, because convection requires a medium, and you are not providing any medium, you have vacuum over here. So the shiny surface of this fin also will be preventing the heat from preventing the loss of heat from radiation. The shiny surface of the walls of this thermos flask, it again prevents the loss of heat through radiation. So how does a thermos flask basically work? First of all, the inner surface is made up of a shiny stainless steel, or could be of glass in older in earlier times. Earlier, it was made up of glass. Then outer casing is made up of plastic. So heat will not be lost via conduction also. First thing, we have ensured that heat does not get lost due to conduction. That's why the outermost surface is made up of plastic, and then above it, in some thermos flasks we see that it is covered with a layer of plastic with the metal also, for the purpose of extra protection and making it strong. Innermost one is made up of stainless steel or glass, right? So we have constructed it in such a manner that heat can neither be lost via conduction, via convection, or via radiation. So that is the working of a thermos flask. Hope you guys have got it. So you guys tell me, what is the purpose of the vacuum inside this?
Sir,
What is
because
the Yeah, I'm listening.
because of the air, sir.
So that heat does not loses through convection. Okay, na?
Yeah.
So the structure, I'm repeating it again. The thermos flask consists of two layers, one placed within the another, and both of them are joined at this neck. This is the neck of the bottle, and there's a gap between the two layers. That is basically, we have evacuated the air from this gap. It is basically vacuum. So it reduces the convection right now, and heat transfer by radiation will also be minimized by what we do, we apply a coating of silver on the inner lining, right? So that prevents the loss of heat via radiation. It's not like you can prevent it 100%, but you can just simply minimize it. It's not like the water will remain cold or hot in this for entirety, for a very long period of time. That's not the case. Hope you guys have understood this.
Yes, sir.
Now, why is it that in um, uh, why in winters we are advised to wear dark colored clothes and opposite in the summer season? You see that we talked about radiation, and we have studied that different objects are emitting radiation. Even the clothes will be radiating some amount of heat.
Sir,
So we
absorb.
absorb also and radiate also. See, we prefer to wear dark color clothes in the winter because dark color clothes absorb more amount of heat than the light colored clothes. Huh?
Yes, sir.
So that is the one of the reasons, and that would be absorbing more amount of heat. So it is absorbing more amount of heat as compared to the amount that it will be radiating. Amount of heat radiated in this case will be less. While in the case of this, what happens? It is reflecting the heat. The heat that is falling on it, it is radiated back into the environment. So whatever, like for example, I'm wearing a very dark cloth. So maximum amount of heat is absorbed by my cloth. If I were to wear a white cloth, the amount of heat will be reflected, basically radiated back. Are you guys getting it or not?
Yes, sir.
So that is the thing.
Yes, sir.
Then there's one more concept left to be discussed in the chapter, that is about thermal expansion. What is its use in our daily life? Once we do that, the chapter would be finished. It would take like few minutes. Basically, in this you will understand the different uses, like about use of thermal expansion in the case of thermometers. You have already studied how mercury is used there. Later on, in in the next class, when we'll be studying the new chapter, for 10 minutes you would understand about the practical application, how you are able to fit this iron rim over a wooden wheel, how the how it is done right now. So that thing we would be studying in the next class. If you guys have any questions, please do let me know.
No, sir.
And then there are some anxiety questions also that has to be done. Okay, then we'll be meeting in next class.
Sir,
Yes, Priyanka, I'm listening.
in a place of a hot climate, it is advised that outer walls of the house be
Mhm.
painted white, right?
We paint it white in color or
Why,
lighter color. Mhm.
why, sir?
Because light colors now will reflect more amount of light, more amount of heat.
Okay, sir.
Lighter colors reflects heat, right? And that is
Okay.
the thing. While darker colors will be absorbing more amount of sunlight, so thereby the lighter color will be reflecting more of the sun's. Particularly, what is it reflecting? It is reflecting the radiant heat. You know that the sun's light consists of electromagnetic radiation also. Electro